Here we go. The last three problems, 14, 15, 16 on 3.2 were apparently are kind of a bear. So I talked to you guys about using the computational model for finding standard deviations. But you know what? I decided we're just going to use the calculator. So at the end of the quiz, I'll show you guys how to use the calculator to compute standard deviation, which will be so much easier. You cannot use it for the first part of the exam. First part of the exam, I'm going to make you do it by hand like you're doing in this quiz right now. But because the first half of the exam is just a basic calculator. A calculator can add, subtract, multiply, and divide. That's it. Right? Maybe square root if you want, but basic stuff only. But questions 14, 15, and 16 in your homework are not basic questions. They involve decimals. They involve more than 5 or 6 items. Right? So it's a little bit harder. So absolutely, you can use a calculator on those. And then Thursday, of course, you have another Connect Math 2. Project Part 2B, I'm not worried about this part. This is Part 3, I think, actually. So mostly, what I'm talking about is this part here. No more than 80% of your data should fall in 2 classes. So in other words, if you have, I don't know, you've got places people want to go, and you've got a bunch of people who want to go to Japan, a bunch of people who want to go to Hawaii, a bunch of people who want to go to Europe, and then you have one wants to go to Korea, someone else wants to go to Singapore, someone else wants to go to Antarctica, someone else wants to go to Australia, 2 people want to go to New Zealand, one person wants to go to the North Pole, whatever. Don't just take all those people and throw them into other and have 10% here, 20% there, 15% here, and then 40% other. Right? Because other should be small. Make those into smaller subcategories like other Asia, or other tropical, or other Europe, or other South Africa. Or sorry, not South Africa, that's only good. One South America, right? And then maybe if you have just a handful that are left over after those, then you can put them into an other, right? Just other. But the other shouldn't really have more than 10% in it, your basic other. So if you have a lot of others, try to group them into sub-other categories. Okay. If you are not sure how to do Project Part 2B, we are not going to go over it in class again because we went over it last class. Instead, what you should do is go to my YouTube channel, right? And if you go, right, I sent you guys all a link. If you need a link, email me. I'll send you another link. Go to the link, subscribe to me, and then if you go to my thing, you can go to my playlists, and you'll see one that says projects here right now. It'll always be in the probably top couple of rows. It'll kind of get bumped as I add new stuff in, but I'll update it so every once in a while it'll get bumped up. But if you go to project, and you click on that, then you'll see over here, there's different parts of it. 1A, 1AB, pause. You can go to Part 2B, night, that's yours. Yours was 16 and a half minutes, versus if you want to see what the evening class asked, there was only 12 and a half minutes. You can go to either one of those and watch them. But you guys apparently asked more questions than they did. At any rate, you can watch and see what we did and talked about in class. It looks like the evening one, my camera was a little more centered, maybe. So that might be more valuable in some ways. Because for some reason that got shoved off. But then you can kind of look at it again, and that will give you an idea to refresh yourself of how to do Project Part 2B. I don't want to spend another 16 minutes going through it when we could be doing other things instead. So just watch that. Project 1. So this is, sorry, not Project 1, Part 1. This is 3.1. Measures of center. So measures of center are things that are kind of at the center of the data set, like averages. Adam, go ahead and read.
Arithmetic mean. The measure of central obtained by adding the values and dividing the total by the number of values. what most people call an average.
right? So our mean is what we usually call the average. Here's some notation, if you guys remember that capital sigma is that sum of all the values, right? That's the sum symbol. X, so if you were not here last class, this is on page 4. If you were here last class, this is on page 4 of your notes from last class, and you should make sure that you have these filled in. X is the variable usually used to represent individual data values. N, your sample size, right? The number of data values in the sample. And capital N, your population size. Also, these two guys are important. X bar, that's our sample mean. Really important. How do you get it? You sum up all the x's. You add up all your values and divide by n, divide by how many there are. Mu, just like the Pokemon Mew, denotes the mean of all values in the population. In other words, you add up all your values in the population and you divide by how many there are. You guys, we'll get to that later. I'll give you time to do that later. And remember, mu can be either written like this, like a weird M, or it will be more like a U. It kind of falls anywhere in that range. Okay, some advantages to the mean. Sterling.
Okay, sample means drawn from the same population. Oh, sample means drawn from the same population tend to vary less than other measures of center. Takes every data value into account.
Keep going.
Disadvantages is sensitive to every data value. One extreme value can affect it dramatically. It is not a resistant measure of center.
Yes, we're going to see that in a minute. I'm going to pull up a video in just a few minutes. We'll see what we mean by that. Not being a resistant measure of center. In other words, it's greatly affected by outliers. Here's your quiz number 1. This is what you should have gotten. So hopefully you guys got that. And 40. Write-off rules for the measure of center, measures of center. It should have one more decimal place than the original data is in. Right, so even if this previous problem had 2 decimal places, you'd still round it to 1 decimal place because your data has no decimal places. So your mean should have 1 decimal place. Median. Brendan.
Median, middle value when the original data values are arranged in order of increasing or decreasing magnitude.
Yes.
Is not affected by an extreme value. Is resistant or is it negative?
It's a is a resistant measure.
Resistant measure in a sense.
Yep. And I'm going to try to pull this up now if I can.
Each and every day, the media fills our heads with numbers. The economy, crime rates, test scores, poll results, and medical studies. It's nearly impossible to get through the day without hearing numbers in the news. When it's not numbers that we're hearing, it's often the results of statistical studies that newscasters and TV show hosts are discussing. Some of the headlines are so poorly thought out that they're funny, while others, those are scary. H.G. Wells once said that statistical thinking will one day be as necessary for efficient citizenship as the ability to read and write. Well, boys and girls, one day is here. The hardest part of statistics is collecting data. Poorly collected data can produce misleading results. Consider the publishing company that is trying to get an idea for a new magazine that will appeal to a certain community. Using their knowledge of elementary statistics, they come up with a simple random sample of residences in that area and call the homes during regular business hours asking about their favorite magazine. The results? Overwhelmingly, the majority of respondents answered Parenting Magazine or House and Garden. The problem? They called during business hours when most people are at work. Stay-at-home moms are most likely to answer the phone during these hours. This sample is not representative of the population of interest, and the results are therefore inconclusive. The publishing company has wasted valuable time and money. Even when appropriate sampling techniques are employed, the questions posed need to be carefully worded not to elicit biased responses. A sample of people were posed the question, researchers at a leading university claim that electromagnetic fields produced by devices like cell phones may cause cancer and other neurological diseases. Do you agree? The vast majority of people in this sample responded with yes. Do you think that the results might differ if the researchers had simply asked, do you think cell phones cause cancer? Certainly. If a leading researcher says it's true, people are likely to agree with that result. Most of us certainly don't know enough about electromagnetic fields to draw a conclusion on our own. Who's going to disagree with professors at a leading university anyway? If that's not convincing enough, allow me to lend an example from my own life. When I was in 4th grade, if someone would have asked me, do you believe in Santa? I would have answered, yes. But when my mom casually asked, Emily, you don't still believe in Santa, do you? Not only did she basically tell me Santa wasn't real, I felt as though I had to answer no. Sometimes bad statistics are produced by the numbers themselves, rather than the collection methods. Careful exploratory data analysis must be done in order to choose appropriate ways to report summarized data. Consider the following true statistic. The average starting salary of geography majors graduating from the University of North Carolina in 1986 was $250,000. Why are UNC geography grads making so much money when nationally graduates in geography are starting at $22,000 a year? Michael Jordan earned his geography degree this year and went on to make over $700,000 in the NBA. You see, the average is computed by taking the sum of the data values and dividing that sum by the number of data values. This measure of center is highly affected by outliers, an individual value that falls outside of the overall pattern of the data. While the average is accurately reported, the statisticians should have used the median or the middle value to report the average starting salary based on the presence of extreme values. Technically, the information gathered in these examples are accurate. They're just misleading to someone who reads the reports and is unaware of the methods used for gathering or analyzing data. Be a skeptic and be educated so that you aren't a victim of bad statistics.
So, we talked before about how people can abuse averages and things like that. This median, so one thing she pointed out was the median is it's resistant measure of center, right? So even though Michael Jordan has a $10 million signing bonus or whatever it is, that doesn't affect the median. It totally affects the mean though, because the mean gets bumped over by these outliers. How do you find the median? First, take your data and arrange them from smallest to largest. If you don't arrange them from smallest to largest, then you're just taking whatever one happened to be written down in the middle, and that has no, I mean, it's just random, right? So arrange your data from smallest to largest or in order, and then take the value in the very center. If two of them are tied for the center, if you have an even amount of data, you'll have two that are tied for the center, take those two and average them. So did you guys do your median already? Everybody all good with that? Should I go over it? So here's the median. I've arranged them in order, and this one's in the center. That's the median. Unfortunately, it also happens to be in the center to start with, but that's okay. That was an unfortunate coincidence. Here, when I first arranged them in order, there are two that are tied for the middle, so I average those, and the median is 0.915. Good, everybody on board with that? Okay. The mode. Ashley, go ahead.
Mode, the value that occurs with the greatest frequency. Data set can have more than one, or no mode. Bimodal, two data values occur with the same greatest frequency. multimodal. More than two data values occur with the same greatest frequency. No mode. No data value is repeated. Mode is the only measure of central tendency that can be used with nominal data.
Right? Categorical data. So you can have the mode of colors if you want, right? But you can't have the average of those colors. Here's your quiz for modes. 110 occurs the most there. The next one, 27 and 55 both occur 3 times. They're tied for the most. So there's 2 modes. Please note, if 55 if there had been one more 55, 55 would have won and there would have been only 1 mode. Because they both have exactly the same and they're tied for the most, there's 2 modes. The bottom one, there's no mode. This is also no mode. 1, 1, 2, 2, 3, 3, 4, 4. Everybody see there's no mode there? None of them occurs more than the other ones? But if I do this, all of a sudden, there are 3 modes. 1, 2, and 3 are all modes. Everybody on board? Okay. There, no mode. Weighted mean. So this is when like our frequency distribution, when some are weighted more than the other ones, some have more frequency than the other ones, or more weight. Then you take every x value, multiply it by its weight. This is like the GPA, right? The grade multiplied by the units, and then divide by, add those up and divide by the sum of the weights, the sum of the units or the sum of the frequency. And then in your quiz problem, the weights were actually not whole numbers, they were decimals. So here, we had decimals as our weights. Did people need another minute to finish this one, or are they okay with this? Good? All right, so 80.7 had a weight of 12%. I'm going to write that in decimal form, 12 cents. 64 had a weight of 4%, 4 cents, 104 cents, 0.04. 90.0 had a weight of 15%, or you write that like 15 cents. $77.8 had a weight of 60%, 60 cents, and 54.6 had a weight of 9%. And you're going to multiply all these. Who has done them already? So I'll tell you what, I will give you guys a minute to try to finish those up. Okay, so if you do that, you'll end up with, don't round along the way, only round at the end. And then if you add up the weights, you end up with 1, or you end up with 1, if you do it by decimal. So you divide by 1, and you just end up with 77.37 as your score.
Is 77.4 okay?
Yeah, I mean, theoretically, it's a mean, so it should have 1 more decimal place than our original data is in.
Okay.
And our data is in these, so in theory, it should have 2 decimal places.
Copy.
Some other people did this. They multiplied by the whole numbers here, by the percents, so times 12, times 4, times 15, times 60, times 9. And they added up the weights and got 100% here, and then divided by 100. That's totally fine as well. Do you guys see what I'm saying?
Yeah.
So some people did that, and that totally works also. So you don't have to change them to decimals, you just have to divide, make sure you divide by whatever this is at the end. Okay. Write-off rules for measures of variation. Again, it should have variation, standard deviation and variation should have 1 more decimal place than the original data is in, same as the mean. And make sure you round only the final answer, don't round along the way, only round at the end. Okay. Carl, please read for me.
Definition is the standard deviation of a set of sample values denoted by S is a measure of how much data values deviate away from the mean.
Good. So in other words, standard deviation is sort of an idea of, on average, how far are most of the data values from the mean. How far do they vary away from the mean, typically? This is for a sample. Remember, if it's for a population, we took every x value, figured out how far it was from the mean, and then we squared those, and then we averaged them, we add them up and divided by n, how many there were. Do you guys remember that? But that's for a population. For a sample, our samples can be off a little bit. So because of that, we kind of give ourselves a little more room for error, and we make this a little bit larger. So instead of dividing by n, we're dividing by n minus 1 to make it a little bit larger. You guys remember my example about $20, dividing it amongst 5 people versus dividing it amongst 5 minus 1 people, 4 people? Use a little bit more, right? That's to give us, so if it's a sample, we kind of give ourselves, we make it a little bit bigger because we're kind of thinking our information might be a little bit sketchy, right? And so we kind of hedge it that way just in case. So this becomes the formula for a sample. The difference between a sample, if you look at your sheet on page 3, I think the bottom of page 3, the difference between the two is that the population is just divided by n. The sample one is divided by n minus 1. Look at the formula. Most of what we're going to be doing in here, are they going to be, is this a statistics class or a parameters class?
Statistics.
So most of are we going to be working with samples or populations?
Samples.
Samples. Those with statistics. So here's our sample standard deviation. The very first step you're going to do is you're going to take every x value and subtract the mean. Figure out how far it is from the mean. That's step number 1. Step number 2 is you're going to square each of those values. Step 3, let's see, blue, green, purple, we'll go purple next, is we're going to add all those up, sum them. And then step 4, divide by n minus 1. And then finally, step 5, we're going to square root all of them. That's the 5th and final step. You'll need to do them, not necessarily with this formula, but you need to be able to do it like you are on the sheet you have in front of you on the exam. Yeah?
Do you add the whole sample before you put it in?
No, you do them each individually. So every single one needs to be done, each individual data value, you find out how far each one is from the mean. And then you take all those differences and you square them all. And then you kind of average them. You add them up and divide by n minus 1. And then take the square root of that. Here's some notation in case you guys didn't forget. If you weren't here again, this is at the bottom of page 4. S is your sample standard deviation. S squared is your sample variance. Sigma is your population standard deviation. And sigma squared is your population variance. Important things to know. So who needs just another couple minutes to finish up problem 6? Okay, I'll give you guys 2 minutes for that. Do you guys want me to do the first one, like part A first, and then let you guys go on part B?
Sure.
Okay.
Sure, my bad.
So here, the first step is going to be take every x and subtract x bar. How far is it from the mean? What's my mean again, guys? I told you.
3.
Yep, x bar is 3. How far is 1 from 3? 2 below. How far is 2 from 3? 1 below. Now, if you don't put the negatives, in a sense here it doesn't matter because you're going to be squaring them anyways. So they're going to all become positive anyways, but, you know, up to you. How far is 4 from 3? It's 1 above. 5 from 3, it's 2 above. And then we're going to square all those. X minus x bar squared. 4, 1, 0, 0, 1, and 4. And then we sum them, we add them up. And then the last step is, and then we divide by n minus 1. How many items do I have? What's my n? 6. Divide by 6 minus 1. And you will get 10 over 5, which is 2. And the last step, S is the square root of that, square root of 2. 1.4. All right, you guys do the next one if you haven't already.
Yes, we do.
What, do you think he's insincere about that? All right, so then here's the next one. X minus X bar is, how far is this? It's 2 away. These are all negative 2 away. These are all positive 2 away. And then when we square them, we'll get 4 for each one of these. And then we have to add them up, sum them. All right, so the bottom line is you can't sum just one number. So think about it that way. If you're summing things, if it says sum of x minus x bar squared, that means that you're summing a bunch of things. This better be a whole bunch of numbers, right? It better be a whole bunch of different things because you wouldn't ever sum just one number. Does that make any sense? All right. And then the other thing is, this always happens first. Because this is multiplication and squaring and things like that. This is addition. Addition is kind of the bottom of the barrel in terms of order of operations. It's kind of the last thing that happens. And then the very last thing is the dividing by n minus 1, because there is invisible parentheses around the numerator and denominator. 6 minus 1. You guys end up with 24 over 5. So 4.8. So then S is the square root of 4.8, which I think is 2.2. And then the last one, common sense. What's the standard deviation of that one? 0. They're all the same. Good?
Yep.
Great. And you can sort of see, like, here are the standard deviations. And you can kind of see, it makes sense, because these ones, how far are these off from the mean? They're all 3 away from the mean. Or sorry, they're all 2 away from the mean. So the population standard deviation would have been 2, but because it's a sample, we make it a little bit bigger, 2.2. Because we're giving ourselves a little more room for error, because our sample might be off a bit. All right, problem number 7. So here, an A, 3 credits is like having little 3 tiny A's. It's a 3-unit class. It counts more than 3 times more than a 1-unit class. Here, there's another A, 4 credits of that. So it's like having 4 little A's there. This is a B. It's like having, it's a 3-unit class. It's like having 3 B's. This is a C. Again, it's a 3-unit class. It's like having 3 C's. And then the F, thank God your F was only one unit, so you only have like one little F there. Good. Now, how do you do this? You guys probably did a table. Is that right? Is that what most people did? Okay. You could do that one. So my first one was an A, which is worth 4 points. So this is the grade point. Grade points. So the A is my grade. The grade point is 4. Is that everybody kind of familiar with how grade points work? So my grade point is 4, and my units were, theirs was 4 units. And then the next one, my grade point was an A, so my grade point again was 4, but it's only 3 units of that. Next one was a B, which is worth 3 grade points, but I only had 3 units of that. My C is only 2 grade points, and I had 3 units of that. And then, like I said, luckily my F, which is worth 0 grade points, was only 1 unit. So then when you multiply these out, these are grade points times units. It's times, that's kind of an ugly, I'll do it like that, times units. 16, 12, 9, 6, and 0 adds up to 43. So I have 43 grade point period times units. What do I want? The unit average or the grade point average? Grade point average, which means I need to divide by units, yeah. Credits.
14.
So that those cancel out. So I need to find my total of my units, which is 14. Divide by 14 units. I know they call them credits. California, we call them units. So these guys cancel out. I'm left with a grade point average. So that's how you figure out which one to divide by. And that ends up being a 3.07. 3.07, which is fine. You could leave it like that because we typically do two decimal places on grade point averages. Or you could follow the rule that you should have one more decimal place than your original data is in and make it a 3.1. Either one of those is totally acceptable.
Do they run it up in real life?
No, they leave it at 3 decimal places, or 2 decimal places in the line. Well, it's because they need to kind of have a little more definition between students who have a 3.4 versus a 3.08. Or 3.6 and a 3, okay. And here it is prettier. And now we're going to take a look at how to do lab problem, the lab problem on the TI-83. So this is page 4 of your old notes from last class, in the middle of the page. I want everybody to pull out your calculator, your TI calculator, and if not, then pop open the computers here. Does, maybe, you know what, I'm going to grab the one that's already open. So hold the calculator. I'll make sure everybody has theirs. And there's TI-84 calculator. On the computer, there's a little calculator with a little white bunny, rabbit emu, on the desktop. And it will, yeah, on the desktop. So bust it open.
That's new. Yeah, we didn't finish the old one.
Quickly stop one of those for a second, because that will take a lot longer. Okay, so everybody has theirs?
Yep.
This is how you do it. So this is for problem, this is for problems, okay, so again, how do you get there? You grab this guy right here, rabbit emu, which is a little white rabbit on the calculator. All right, so everybody see the stat button right in the middle? Turn it on down here if you haven't turned it on. It's down here in the bottom left corner. And then hit stat, which is right here in the middle. Everybody see it? Right there in the middle? Hit stat. Everybody do it.
Stat.
And then the first one is edit. So see where it says number 1, edit? You can either hit enter or you can hit 1. And it will pick that one. Okay, my table has stuff in it. My list has stuff in it. So I'm going to go, if you go, see how my cursor's on the 22, everybody look up. See how my cursor's on the 22? Go up so it's on the L1, hit clear, enter, and that list will clear out. All right, so we're going to do this lab problem in the middle of page 4, the example. The one we said skip on, we're going to do it with the calculator. So it's putting in 22, and you can just use your, if you're using the computer, you can just use your little number pad over here, and enter key and the down, left, right keys, those all work great. So 22, enter, 22, enter, 26, enter, so 24, enter, and 23, enter.
You said 22 twice, right?
Yeah, there's two 22s. So we're working on this problem here. All right, so you want to put those numbers into your list. List 1.
Yes.
Everybody have it? Yes. Oh, yours must have, you already did that. All right, you guys did it? Okay, so now, everybody has this entered into a calculator. We're just going to go back to stat. So hit stat again. And then go to calc. So arrow to the, see this calc right here? Arrow to the right where it says calc. We want one variable stat. We have one variable here, chocolate chips. That's number of chocolate chips, that's our only variable. So we have one variable stats. We're going to hit enter on that one. Most of you will have a regular calculator where you just get this. Some of you may have a fancy one where it says list, colon, and ideally L1 is already in there. Anybody have that? Does anybody have it where L1 is not in there? Okay, good. And then your frequency, if you have the fancy one, you want that blank with nothing in it. So if something's in there, go down there and just hit delete. And that should delete or clear, that should clear it, yeah.
After you hit count, you hit enter.
Oh, yeah, hit enter. So I'll show you again. Stat, calc, enter. Or you can hit 1 because you want one bar stats. See where it says one bar stats here? You could just hit 1. So that's the one you want. Oops. Ooh. Stat, calc, one bar stats. And if you have a basic one, it defaults to list 1. You put everything in list 1, just hit enter. Yep. It'll give you that. If you have a fancy one, you have to put L1 in first. Or for some reason you put it into list 2, then you should put in list 2.
Oh, and save it.
So if you want list 1,
But they have.
do you guys all see how list 1 is in blue right here? I'll give you guys a minute. Did you guys all, everybody good with this, or did anybody have questions or issues? See if your friends can help you out. All right. All right, you guys, listen up. So see how this is, there's an L1 right here in blue. Everybody have that? It's either in yellow or in blue on your calculator. To get that one, you have to hit the second key, because the second key is the same color as that. Here it's blue, this is blue. So I hit second, and then that would give me L1. So, you see how L1 pops in right there? I hit enter, it'll pause, show me everything that's in list 1. It just shows me what list 1 is. So that's how you get, if you have the fancy weird one, I could do second L1 here, and it would do one bar stats of L1, and then there's my data. What's my X bar? What's X bar stand for? Sample mean. My sample mean is 23.4. This is the sum of my X's. So in other words, if I add up all my X's, I get 117. This is my sum of my X's squared. That means if I squared every X and then added them, I'd get 2749. And then, see how it gives me Sx and sigma x? Everybody see that?
Yeah.
You guys look up here for a second, this is important. Sx and sigma x. Sx is what? Sample standard deviation. Sigma x is what? Population standard deviation. It gave me both. Here's the problem. The calculator doesn't know whether you gave it the whole population or whether you gave it a sample. You were the smart one. You know whether you gave it a population or a sample. So you know which one to pick. Which one is this? Is this, do we give it a whole population or just a sample? A sample. So here, we know that we gave it a sample, we should be looking at SX. Sigma X is worthless, it's not valuable, because we didn't give it a population. We gave it a sample, so we should be using SX. Everybody, does that follow? That's important, right? So if you know if you gave it a sample or a population, if you give it a sample, then you should be using SX. If you give it the whole population, then you can use sigma X. Yes?
On the test, are we going to know whether or not the variables of the data set that we're given is a part of the population or a sample?
You should be able to figure it out. If I say the sample was taken and these are the values, then that's from sample. You can always ask me and say, is this from the whole population? And if it says sample in there, I'm going to say, what do you think? Right? And if for some reason I left out the word population, then there it is. There is some probability stuff where the whole thing is theoretical, so then it would be a population, but it won't give you an S then. It knows, it's smart, it knows better. And we'll talk about that later. All right, so SX, sigma X. And you notice how SX is a little bit larger than sigma X? It's because we're dividing by n minus 1 instead of dividing by n. We're giving ourselves a little more room for error because we're likely to be off a little bit. Okay, good. So use this to find your standard deviation for problems 14, 15, and 16 on 3.2. Otherwise, you'll save yourself lots of head banging. Okay. I should probably write that in there. Stat. Edit. Enter. Let's take a break. We'll take a break till 45 after, 44 after maybe? Let's do that. And then we'll start back.